Hello. Here is the video going over the Unit 2C review, graphing rational functions. So the first question asks us to identify the horizontal asymptote of each rational function. So first and foremost, I want to go over the different scenarios that we have with horizontal asymptotes. And they all come from comparing the degrees of your numerator versus the denominator. So if your degree of the numerator is greater than the degree of the denominator, your horizontal asymptote actually will not exist. So this one actually does not have a horizontal asymptote or a HASI. Instead, it has a slant asymptote, which you'll see in one of the graphing examples. Another scenario is if the degree of the numerator equals the degree of the denominator. And what's going to happen there is your horizontal asymptote is going to take the form of y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. And our last scenario is when the degree of the numerator is less than the degree of the denominator, and when that happens, your horizontal asymptote is going to be the line y equals 0. So the first thing I want to do is actually compare all of my degrees. So if I look at my numerator, degree is your highest exponent, which in this case is 1. In my denominator, the degree is 2. So the degree on top is smaller, so that's going to create a horizontal asymptote of y equals 0. For the second one, I'm going to go ahead and rewrite my numerator. I'm going to rearrange it and write it as negative x plus 5. And then I'm going to look at my degrees. So again, degree on top is 1. Degree on the bottom is also 1. So that means my horizontal asymptote is going to be y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Well, the leading coefficient of the numerator is negative 1. And the leading coefficient of the denominator is positive 1. So I have negative 1 over positive 1, which is just negative 1 for that horizontal asymptote. All right, now if I look at this third one, my degree on top is 3. Degree on the bottom is also 3. So once again, we have the situation where it's y equals a over b. A is the leading coefficient of the numerator, which is 1, and b is the leading coefficient of the denominator, which is 2. So that means my horizontal asymptote is the line y equals 1/2. For the fourth one, degree on top is 2, degree on the bottom is 1. So that means you do not have a horizontal asymptote, because you would have a slant asymptote instead, because your degree on top is bigger. For the fifth one, degree on top is smaller than the degree on the bottom, so that's going to be y equals 0 for the horizontal asymptote. And finally, for the last one, degree on top is bigger once again than the degree on the bottom, so that means you are not going to have a horizontal asymptote. Instead, you are going to have a slant asymptote. All right, so let's actually get into some graphing. So when you're graphing, you want to find all of these individual pieces of your function and use that to create the graph. First and foremost, we always want to start by factoring. So my numerator is just going to stay as x minus 2. My denominator can factor to x plus 2 and x minus 2. So I notice right away that my x minus 2's can cancel. So that's going to leave me with 1 over x plus 2, and I'm going to call this my leftover function as I work through some of my other examples, but I'm going to go ahead and cancel out that x minus 2. Your domain is going to have restrictions on all the values that x cannot be, because you cannot divide by 0. So x cannot be negative 2 from this factor, and x also cannot be positive 2 from that factor. Even though that factor cancels out, we do need to take it into consideration into our domain. Your x-intercepts or zeros will come from the numerator of your function. So if I look at my numerator, it's just 1. I don't have any variables up there. There's no x's up there. So that means this actually is not going to have any x-intercepts. For my y-intercept, I'm going to plug in 0 into my leftover. So I have 1 over 0 plus 2, which is just 1/2. So my y-intercept is at 0, 1/2. The wholes will come from your canceled out factors. So the factors that canceled out were x minus 2's. So that means I'm going to have a whole at the 0 of the canceled factor. So my canceled factor was x minus 2. So my x-coordinate of the whole is going to be a positive 2. And to find the y-coordinate, I'm going to take it and I'm going to plug it into my leftover. So that becomes 1/4. So I'm going to have a whole at 2, 1/4. Your VASI stands for vertical asymptote. So your vertical asymptotes come from your denominator. So in my denominator, I have an x plus 2 left over, which means I'm going to have a vertical asymptote at the line x equals -2. And horizontal asymptotes we just talked about with the previous example. I can go back to my original function and I can see that my degree on top is 1 versus my degree on the bottom, which is a 2. So that means my horizontal asymptote is going to be the line y equals 0. And when you have a horizontal asymptote, you will not have a slant asymptote and vice versa. So if we had a slant asymptote, we would not have a horizontal asymptote. So I'm going to make a couple notes along the side just in case you need it. So x-intercepts will come from the numerator. Y-intercepts come from plugging in 0. Your wholes come from factors that canceled. So canceled factors. Vertical asymptotes come from your denominator. Your horizontal asymptote and your slant asymptotes essentially come from comparing your degrees. So I'm going to make a note, compare degrees. We will actually have to find a slant asymptote in a little bit, and there is a method for doing that, but since this one doesn't have a slant asymptote, I'm not going to bother explaining it right now. Okay, so to graph, I'm going to go ahead and start by graphing my asymptotes. So I have a vertical asymptote at x equals -2. So I'm going to draw a vertical dotted line at x equals -2. I also have my horizontal asymptote at y equals 0, which just so happens to be my x-axis. I can also plot my points. So I have a y-intercept at 0, 1/2. I'm going to put that right in the middle of that grid. And I have a whole at 2 1/4. So it's a little closer to that horizontal asymptote. And really that's all I have to go off of as I'm creating this graph. But I can sketch the rest of the graph using some logic. So I can connect the whole and the y-intercept, and I can see that I'm increasing. And I'm just going to keep increasing as I approach my vertical asymptote. Similarly, I can go in the opposite direction past the whole and continue to taper towards that horizontal asymptote. Now, rational functions always have multiple pieces. So I have this purple curve on the top right-hand side of my graph. So that means I'm going to have another curve on the bottom left-hand side of my graph. And what ends up happening is at these vertical asymptotes, typically your graphs will go in opposite directions. So since I am increasing towards the vertical asymptote on the right-hand side, that means I will be decreasing towards the vertical asymptote on the left-hand side. So I can draw that piece, and it's still going to taper over towards the horizontal asymptote in that direction. And there is the graph for number 2. All right, number 3, I'm going to go ahead and start by factoring again. I do notice right away that in my numerator, they're all divisible by 3. So I'm going to go ahead and factor out the 3 first. And then I can just continue to factor. So this is going to leave me with 3. Two numbers that multiply to -3 and add to 2 are +3 and -1. In my denominator, two numbers that multiply to 3 and add to 4 are +3 and +1, and I can see that my x plus 3's are going to end up canceling out. So my leftover function is 3 times x minus 1 over x plus 1. For the domain, you are going to list all of the restrictions, even for the ones for the factors that canceled. So I'm going to have a restriction at -3, since x cannot be -3, and also -1 from the other factor. X-intercepts come from your numerator. So I can see right now that I do actually have a factor in my numerator. It is this x minus 1. So that means I'm going to have an x-intercept at +1. So I'm going to go ahead and write my ordered pair, +1, comma, 0. By the way, anytime you're finding zeros of a factor, what you are doing is you are taking that factor and setting it equal to 0, which is why typically it just ends up being the opposite, but sometimes it's a little more complicated if you had like a coefficient in front of your x. But yeah, more often than not, it is the opposite. Okay, y-intercept comes from plugging in 0. So now I'm going to plug in 0 into my leftover function, and that leaves me with 3 times -1, which is -3, over +1. So I'm going to have my y-intercept at 0, -3. Your whole comes from the canceled out factor. Your canceled out factor had a 0 at -3. And again, to find my y-coordinate, I'm going to take that -3 and plug it into my leftover. You're always plugging into your leftover. So let's see, that leaves me with 3 times -4, which is -12, over -3 plus 1, which is -2. So that reduces to a +6. So I'm going to have a whole at +6. Vertical asymptote comes from the factor that was left over in the denominator. So that's going to be x equals -1. Your horizontal asymptote, let's compare our degrees. Degree on top is a 2. Degree on the bottom is also a 2. So that means my my horizontal asymptote is going to be in the form of y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. So that is 3 over 1, or just y equals 3. And of course, since we have a horizontal asymptote, you are not going to have a slant asymptote. So let's go ahead and start graphing. So I have my vertical asymptote, my VASI at -1. So I'm going to plot my vertical line at -1. I have my horizontal asymptote at y equals 3. So I'm going to go to 3 on my y-axis, and I'm going to draw my horizontal asymptote. And let's go ahead and plot some points. I have an x-intercept at 1, 0. So that's this point over here. I have my y-intercept at 0, -3. So that's down here. And I have a hole at -3, 1, 2, 3, and 6. 3, 4, 5, 6. Okay. So now to connect these points logically, I can connect the 2 points on the bottom right-hand side together. And I can see that I'm increasing to the right. I'm going to go ahead and taper off towards my horizontal asymptote and approach my vertical asymptote. And at vertical asymptotes, they typically go in opposite directions. So I'm going to go ahead and start at the hole and start heading towards that vertical asymptote and taper off towards that horizontal asymptote. And there is your graph for number 3. Number 4, I'm going to go ahead and start factoring again. So 2 numbers that multiply to 5 and add to -6 are x minus 5, x minus 1 over x minus 2. For my domain, x cannot be +2. I actually have 2 x-intercepts this time. I'm going to have one at 5, 0, and one at 1, 0. My y-intercept comes from plugging in 0. So I have 0 minus 5 times 0 minus 1 over 0 minus 2. Let's see, that gives me -5 times -1 is +5 over -2. So that'll be -5 halves. For the whole, we didn't have any factors that canceled, so there's no holes this time. My vertical asymptote comes from the denominator, so that's x equals 2. And my horizontal asymptote, let's compare our degrees. Degree on top is bigger than the degree on the bottom, which means in this scenario, we don't actually have a horizontal asymptote. Instead, we have a slant asymptote. Now, to find your slant asymptote, what you're going to do is you are actually going to divide your polynomial. So I'm taking x squared minus 6x plus 5 and dividing it by x minus 2. Now, there's two ways that you can divide this. You can use long division or synthetic division. I'm a big fan of synthetic division because it is quicker. So for synthetic division, I want to find the 0 of this factor, and that's going to help me do my synthetic division. So the 0 of this factor is at 2. So when I set up my synthetic division, I'm going to put 2 in this little box, and I'm going to list out my coefficients of the polynomial that I am dividing into. So I have 1x squared minus 6x plus 5. I'm going to leave a little space, and I'm going to put another little box underneath that 5. That is my remainder box, because sometimes when you divide, you have a remainder. All right, let's run through the synthetic division. Your first term will always go straight down. So I'm going to have my 1. I'm going to take 1 and I am going to multiply it by what is in the box. So 1 times 2 is 2, and that's going to go underneath my negative 6. I can go ahead and combine straight down. Negative 6 plus 2 is negative 4. I'm going to take that negative 4 and multiply it by 2 again, which is negative 8. And I can combine, and that leaves me with a remainder of negative 3. Now, when you are finding your slant asymptote or your SLAC, we actually don't care about the remainder. So right here, what we have left over is our function. So since we had started with x squared, that means this is going to be 1x minus 4, and that will actually represent your equation of your slant asymptote. So y equals x minus 4. Now, if you wanted to divide that using long division, you totally could, and you would end up with the same exact answer. Okay, so let's graph this. I'm going to graph my vertical asymptote at x equals 2. And we do not have a horizontal asymptote. Instead, we have a slant asymptote. It is a linear function, so it's in slope-intercept form, so my slope is 1, since that's the number in front of my x, and my y-intercept is negative 4. So I'm going to start at negative 4, and I'm going to go up 1 over 1, up 1 over 1, and then you can go ahead and sketch your slant asymptote. You can plot points if you want to. If you'll notice, I'm just plotting dotted lines as I move with my slope, just because I know it's going to be a dotted line anyway. Okay, let's go ahead and plot our points and see if we can sketch the rest of this graph. So I have I have x-intercepts at 5, 0, and 1, 0. So 1, 2, 3, 4, 5. So here is one x-intercept. Here's my other x-intercept. I also have a y-intercept at 0, negative 5 halves. So negative 5 halves as a decimal is negative 2.5. So that puts our y-intercept right here. And I'm going to go ahead and connect the two purple points that are on the left side of my vertical asymptote. And what I'm going to do is I'm going to connect them, and I'm also going to approach my vertical asymptote as well as approach my slant asymptote. And that other purple point is going to give us the other side where I approach the slant asymptote from the right and your vertical asymptote on this side. And there is your graph for number 4. All right, last set of questions. For this one, I am giving you the graphs or the information, and what we have to do is we have to write the equation. So I'm going to go ahead and set up an f of x equals and a giant fraction bar because we're going to leave this in factored form. And what I want to do is I want to pull pieces of information from the graph to be able to write an equation. So a couple of things that I notice right away. I notice that I have an x-intercept or a 0. I'm going to say my x-intercept is at negative 1, 0. And x-intercepts come from factors of your numerator. So that means I'm going to have a factor of x plus 1 in my numerator. since it gives me an x-intercept at -1, 0. I also notice that there is a hole. So the x-coordinate of the hole is 3. The y-coordinate we don't really know. I'm just going to go ahead and approximate it as 1.7. Could be, I don't know what it is exactly. It's just a good approximation. And so the hole has an x-coordinate of 3, so that means it came from a factor of x minus 3. And holes come from factors that cancel. So if I have an x minus 3 on the top, then that means I also need to have an x minus 3 on the bottom, because that would result in the cancellation to create the hole. The other piece of information that I notice is that I have a vertical asymptote. So my vertical asymptote is at x equals -2. Vertical asymptotes come from factors in your denominator. So since it was x equals -2, the factor is x plus 2. And the other thing I notice is the horizontal asymptote. So I can see my horizontal asymptote is y equals 2. And since my horizontal asymptote was a form of y equals a number that's not 0, that means it was originally coming from y equals a over b. So that means those are the leading coefficients of your numerator and your denominator. So 2 is the same thing as 2 over 1. So I can just go ahead and put 2 on top, 1 on the bottom. 1 on the bottom is totally optional. And there is your equation. We are going to do the same thing for number 6. So I'm going to start with f of x equals, I'm going to set up a fraction bar, and then I'm going to start setting up my factors. So I notice that there is a hole at -2 something. We don't really care about what the y-intercept is, since it's not really part of the equation. I mean, you could use it. You could find it later on once you write your equation if you really want to. But the hole is at -2, comma, I'm going to go ahead and just put a question mark because it doesn't really matter at this point. So since I have a hole at -2, that means the factor comes from x plus 2. So I'm going to put an x plus 2 on the bottom and an x plus 2 on the top. Let's see, I have an x-intercept. There's my x-intercept, or my 0, at 4, 0, and that factor comes from my numerator. So I'm going to write x minus 4. What else do I have? I've got my vertical asymptote. Vertical asymptote at x equals 3. So that means it came from a factor of x minus 3, and that comes from the denominator. And last but not least, I have this horizontal asymptote at y equals -3. So same deal as number 5. Since my horizontal asymptote was -3, that means my leading coefficients are -3 over 1. And once again, the 1 on the bottom, totally optional. And there is your equation. All right, let's keep going. So number 7, I actually have my equation, or I have my characteristics listed out instead of looking at the graph. So same thing, I'm going to start by setting up my giant fraction. I have 2 x-intercepts, so one at -3, so that means it came from a factor of x plus 3, as well as -4, so that comes from x plus 4. I have my y-intercept at 0, -3. That's not really going to give me any information about the factors. I have a hole at -5 and 1 over 28. So that means I had a factor of x plus 5 that cancels. So I'm going to put one on top and on bottom. I also have 2 vertical asymptotes. So I have one at -1, so that came from a factor of x plus 1. And I also have one at x equals 2, so that comes from a factor of x minus 2. And last but not least, I have my horizontal asymptote, which is 1/2. So again, that comes from y equals a over b, so that means a is 1 and b is 2. Now, if you wanted to verify that your equation was correct, you could use the information from your y-intercept, plug in zeros for all of your x's to make sure that you get a -3. Personally, I'm not going to do that right now because I believe my equation is correct. All right, so there's your equation. The key with equations is really understanding where these characteristics come from. X-intercepts come from the numerator. Wholes come from canceled factors. Vertical asymptotes come from your denominator. And your horizontal asymptote, if it equals a number, it is y equals a over b, and those are going to be the coefficients for your numerator and your denominator. All right, so that concludes the video going over your test review. Good luck on your test.